All right, so we'll get back to section 3.7 here. We're talking about rational functions. And now one way to graph a rational function is to use what we know about transformations. In the last video, I mentioned that I'm not really showing anything new here. You know, like the only new thing is the concept of an asymptote, which is a boundary that the graph approaches, but it's never going to get there. Okay? Now, the more important thing in this section is going to be this other method for graphing a rational function, right? Because it's hardly ever going to be the case that you're going to be all set up in some convenient manner to graph using transformations. So it says to sketch the graph of any rational function, f of x equals p of x divided by q of x, you're going to follow the 6 steps that are below. Step 1, you're going to state the domain of f. Step 2, you're going to write the equations of the vertical asymptotes for f. Now, the equations are going to come immediately from just knowing the domain of the function, right? Because any number that you're throwing away is going to create a vertical asymptote on the graph. Now, there's a note there which says, make sure that the function is in the lowest terms before identifying the vertical asymptotes. Now, that is important. Okay, that's going to be important for one example that we'll see in this worksheet here. Step 3, write the equation of the horizontal or oblique asymptote for f. Okay, so you're going to get that by dividing if the degree of the top is equal to or one more than the degree of the bottom. Okay, you're going to have to divide. Otherwise, if the degree of the top is less than the degree of the bottom, you're just going to write y equals 0. Okay. The graph will, there's a note there. It says the graph of f will have either one horizontal asymptote or one oblique asymptote, or else it doesn't have any of them. Okay. There are functions that have 2 horizontal asymptotes, but you guys aren't going to have to worry about anything like that. Okay. Step 4 then says to determine the points, if there are any, where the graph of f will intersect the horizontal or oblique asymptote. Okay, so maybe I should be more clear about an asymptote, what I mean by that. In the definition on the previous page, it says that an asymptote is a linear boundary which a graph approaches, but it's never going to touch. That's actually not completely true. Okay, so you can cross an asymptote. Okay, now your work in step 4 will tell you if you're going to cross the asymptote or not. Okay, the whole idea with an asymptote is once you start heading outward towards infinity or a negative infinity, you're not all of a sudden going to make some jump at some random spot. Okay, or if that did happen, you would know what points that happens at from your work in step 4. Okay. As a note, the graph cannot intersect a vertical asymptote because otherwise it wouldn't be a function then. So you're only going to check if the graph will intersect horizontal or oblique asymptotes. Step 5 is where we want to determine the intercepts for f, all the x and y intercepts. And then step 6, you're going to plot more points as is necessary to sketch a complete graph of f. Now, usually your work here in these previous 5 steps are going to be very important to get the graph, but it's not going to tell you, everything that you want to know about the graph. Okay, so usually you're going to need, a couple more points on the picture to be able to completely sketch the graph. Okay, so that's going to be in step 6. And I would also add to this, you can check your answers using a graphing calculator. Okay, so if you plug in the function into y1 and then hit graph, you should be able to get the graph of these functions that we're going to be drawing here. Okay. So let's take a look at problem 3. we want to graph each rational function using the 6 steps that are given above. Okay, and by the way, your book is doing the same thing here. Okay, it's giving you a list of steps that you're going to follow. Okay, all right, so here's the function that we have. We got f of x equal 2x plus 1 divided by x minus 3. And I want to graph f of x. So step 1 is where we have to state the domain of f. Okay, I know I can't divide by 0, so just don't let x be 3. Okay, the domain therefore would be the set of all x such that x is not equal to 3. Okay, we can use any other number, that's fine. Now because we're throwing 3 away as a result of the domain, we're going to have a corresponding vertical asymptote on the graph at x equals 3. Okay, so in step 2, I'm going to have a vertical asymptote at x equals 3. And I mentioned this already, but be sure that whenever you're writing the equations of asymptotes down, that they're written as equations. Okay, don't just write 3. Okay, because if you just write 3, that can be misleading. Are you talking about x equal 3 or y equal 3? Because y equal 3, that wouldn't be a vertical asymptote. Okay, so I need to write x equals whatever number I get. Step 3, I need to write the equation of the horizontal or oblique asymptotes. Okay, so the degree of the top is 1. I get next up top, and the degree of the bottom is 1. Whenever the degree of the top is the same as the degree of the bottom, like it is here, I need to divide to get the equation of the horizontal asymptote. Now I can know at this point that I'm going to have a horizontal asymptote. It's not going to be at y equals 0, though. It's going to be at y equals some other number. Okay, and to get that number, we'll use division. So the expression that's in the denominator is going to go outside the division bar. The expression that's up top is going to go underneath the division bar. Now I guess if I wanted to, I could use synthetic division because I'm dividing by a binomial, something with just 2 terms here. That'd be fine. You'd still get the same result. I've already got the long division set up, so I'm gonna stick with that. Okay, and let's see. We're thinking of an expression such that when we multiply it by x minus 3, the leading term is 2x. So I want a 2 up top. 2 times x minus 3, that'd be 2x minus 6. And we're subtracting that from 2x plus 1. So 2x minus 2x, that's 0. 1 plus 6 is 7. Okay, and so 7 would be the remainder. Now the complete leftover information is always going to be a fraction that you're going to add to the quotient. Okay, so I'm going to say plus 7 divided by x minus 3. There, I've divided this completely. And by the way, the directions on a quiz or on a test are going to be where I want you to divide completely. Okay, because I have students that will just say, no, the answer is 2. No, you didn't finish the division. Okay, it'd be 2 plus 7 over x minus 3. That's the answer. Okay, now we want to know where there's a horizontal asymptote on this graph. Okay, so what I had said on this page is you're going to disregard the remainder. Okay, so if I disregard the plus 7 over x minus 3, I get y equals 2. That would be the horizontal asymptote. Now also, I can do it like this. If I start with the leftover and I compare the degree of the top to the degree of the bottom, the degree of the top is 0. I don't have any x's up top. And the degree of the bottom would be 1. 0 is less than 1, right? So y equals 0 would be a starting place to use as a horizontal asymptote. It's just I'm adding 2 to 0. So ultimately, y equals 2 becomes the equation of the horizontal asymptote. Okay? Now, the leftover information will always go to 0. If it does not go to 0, you haven't finished dividing yet. Okay, so that's why I said on the previous page there, you're just going to disregard the remainder. Okay. Now in step 4, I want to know, do I cross the horizontal asymptote y equals 2? To figure that out, I'm going to set the function equal to the asymptote, and I'll solve for x. Okay, so I got 2x plus 1 over x minus 3 equals 2. And let's solve for x. So if I multiply both sides by x minus 3, 2x plus 1 equals 2x minus 6. Okay, and if I subtract 2x from both sides, those are gone. And that's going to leave me with 1 equals negative 6. I know 1 does not equal negative 6. That's not a true statement, right? But x fell out completely. And we got something that's not true. So what that means to us is that there's no point where the graph will intersect the horizontal asymptote. Okay, so I'm just going to write none for that, which is good because so I don't have to worry about that for this problem. Now in step 5, I need to determine the intercepts for f. So the x and y intercepts. To get a x-intercept, I need to let y be 0 and solve for x. To get a y-intercept, I need to let x be 0 and solve for y. Okay. So when I let y be 0, y and f of x are the same thing, right? So let's set the function to be 0 and solve for x. I got 2x plus 1 divided by x minus 3 equals 0. And if I multiply both sides of that by x minus 3, that's going to leave me with 2x plus 1 equals 0. Subtract 1 and divide by 2, so x is negative 1/2. To get the y-intercepts, I need to let x be 0, and if I plug 0 into this function, I got 1 divided by negative 3. All right, so this graph is going to have two intercepts on it, which is going to occur at when x is negative 1/2 and y is 0. Okay, and then when x is 0, y is negative 1/3. So those 2 points would be on this graph. Okay, so now we're on step 6. We're going to begin sketching this graph. So I'll just run through the information that I've already got here, and I'll get it on the picture. So I'm drawing f of x, right? The domain is all real numbers except for 3. Because I threw away 3, I'm going to have a vertical asymptote at x equals 3. Okay, so go ahead and make a dotted line there at x equals 3. And through division, we found that there's a horizontal asymptote at y equals 2. So go ahead and make a dotted line at y equals 2. We don't cross the horizontal asymptote, so that's good. We don't have to worry about that. And then there's 2 points on the graph there. So negative 1/2, 0 is right here. And then 0, negative 1/3 is right there. Okay, so after doing all that, I only know 2 points on the graph. Okay, which is why I'm saying, you're going to plot more points as it's necessary to draw a complete graph. Okay, it's usually going to be necessary there to gather up some more points on this picture. Now the stuff that I've already got on the graph is very important. It's very key, So at this point, let me use a table of numbers, and I'll select some x values and get some corresponding y values and then plot those points. So if I let x be 2, 2 times 2 is 4 plus 1 is 5, divided by negative 1, that'd be negative 5. Okay, so the point 2, negative 5, that point would be on the graph. If I let x be negative 2, 2 times negative 2 is negative 4, plus 1 is negative 3, divided by negative 5, that'd be 3/5. Okay, so there's the point negative 2, 3/5. Okay, now keep this in mind that the graph has to flow with the asymptotes. I got a vertical asymptote here, and I got a horizontal asymptote here. I'm getting these points, and so I know that the curve has to flow with the asymptotes. So I think what's going on is I'm going to be starting off in quadrant 2. I'm going to be below the horizontal asymptote and pulling away from that slightly. And I'll come down, I'll pass through these points here, the x and y axes also, and I'll continue to head downward. I'll pass to the point 2, -5. And I'll just continue to head downward, getting closer and closer to this vertical asymptote, but with the understanding that I'll never get there. Okay? Now on the right side of the graph, if I continue to select some numbers, like if x is 4, 2 times 4 is 8, plus 1 is 9, divided by 1 is 9. Okay, so the point 49 would be on the graph. If I let x be 5, 2 times 5 is 10, plus 1 is 11, divided by 2. 11 halves, that's the same as 5 1/2. Okay, so that'd be the point 5, 5 1/2. Okay, and I'll just take one more value here. If x is 6, 2 times 6 is 12, plus 1 is 13, divided by 3 is 13 thirds. 13 thirds is the same thing as 4 1/3. Okay, so I have the point 6, 4 1/3. That's on the graph. Okay, and again, I see this vertical asymptote and this horizontal asymptote, and I'm getting some points in the upper right-hand region. So I think what's happening for the rest of this curve is I'm going to be coming down the vertical asymptote. I'll be to the right of that. And I'll be pulling away from that slightly. I'll pass through these points. And then I'm going to be approaching the horizontal asymptote from above it. Again, with the idea that I'll never get there, though. Okay, so what we have here would be the answer. Now, keep this in mind. So two things here. So you shouldn't need lots and lots of points. Okay, really all I needed was 1 point to be in this upper right-hand region to know the rest of the story. Okay, so you know if x is 5, y is 11 halves, and I plot that point, I know that the curve is going to come down the vertical asymptote and approach the horizontal asymptote, right? So it's got to behave with respect due to the asymptotes. Okay, it's got to approach those asymptotes. Okay. Now you can plot as many points as you want, but keep in mind that you shouldn't need lots and lots of points here. Okay. And another thing too is so how do I know that I don't have any graph like down here? You know, how do I know that? Well, because I have a function, right? So it's going to pass the vertical line test. So me plotting just 1 point up here tells me the rest of the story about what's happening to the right of x equal 3. It means that I'm above the horizontal asymptote. I'm not going to have any graph down here, right? So again, you should not need lots and lots of numbers in the table, okay? Just gather up a couple more points and finish the drawing. And this would be a rough sketch of the graph of f of x, okay? We'll go ahead and stop the video right here, and I'll show you some more in the next one.